Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that AC equals to 2 units, BC equals to 8 units, and we also know that DE is parallel to AB, and DE is a natural number, that is to say the size of DE is a natural number. And we also know that G is the centroid of triangle ABC. The centroid of any triangle is a point where the three medians intersect with each other. Okay? And we want to find out the value of DE. So, first of all, we have a rule. I will call it rule number 1. Rule number 1 states that the centroid of a triangle G is the centroid of this triangle. So this centroid of triangle ABC, that is actually at point D, divides the median in a ratio that equals to 2 to 1. So I will read rule number 1 again. Rule number 1 states that the centroid of a triangle, that is to say G is the centroid of this triangle, so this centroid G divides the median of the triangle. In this case, the median of triangle ABC is CF, so it divides the median in a ratio that equals to 2 to 1. So actually, if we have triangle ABC, that could be any triangle, and we know that AD is the median of triangle ABC, that is to say AD divides side BC in 2 equal parts, so AD bisects BC. That is to say BD equals to DC. BD equals to DC, and we also know that point G, at point G we have the centroid of triangle ABC. Then this centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Okay, so we can write down that if AG equals to 2 units, then GD will be equal to 1 unit. Okay, if AG equals to 2 units, then GD equals to 1 unit, or in other words, AG is 2 times GD. AG equals to 2 times GD. Okay, so that is the rule of the centroid, rule number 1. So we actually can implement rule number 1 in our drawing, because in our drawing we have the centroid G of triangle ABC, and according to rule number 1, the centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. Okay, so I'll write it down. If CG, according to rule number 1, if CG equals to 2 units, then GF will be equal to 1 unit. Okay, if CG equals to 2 units, then GF will be equal to 1 unit, or in other words, CG is twice as large as GF. That is to say, CG equals to 2 times GF. According to rule number 1, we have this equality that states that CG equals 2 times GF. And if we define CG as 2x, that is to say, if CG equals to 2x, then we can substitute CG in this equality by 2x, and we will get that 2x equals 2 times GF. Here we will divide this equality by 2, and we will get that GF equals 2x. So we actually found out that if CG equals to 2x, then GF will be equal to x. So if CG equals to 2x, then GF will be equal to x. Okay? And we actually have another rule number 2. According to rule number 2 is true in any triangle. Rule number 2 states that in any triangle, so if we have triangle ABC that could be any triangle, and we know that DE, this line segment, is parallel to BC. So if in triangle ABC that could be any triangle, DE is parallel to BC, then the following equality is true. AD over DB will be equal to AE over EC. AE over EC. So this equality is true. If DE is parallel to BC, then AD over DB will be equal to AE over EC. Okay, so again we can implement rule number 2 in our drawing, because in our drawing we know that DE, line segment DE is parallel to AB. DE is parallel to AB, therefore, according to rule number 2, if we relate to triangle ACF, if we relate to the green triangle ACF, so actually in the green triangle ACF, we know that DE is parallel to AB. So in the green triangle ACF, according to rule number 2, we will get that CD over AD equals to CG over GF. I will repeat again. In the green triangle ACF, we know that DE is parallel to AB, therefore, according to rule number 2, CD over AD will be equal to CG over GF. Okay? In the green triangle ACF, because of the fact that DE is parallel to AB, therefore, according to rule number 2, CD over AD will be equal to CG over GF. That is actually according to rule number 2. Okay? But what is the value of CG? CG equals to 2x. And what is the value of GF? GF equals to x. So in total we got that CD over AD equals to 2x over x. 2x over x is 2 because 2 will get cancelled. X over x is 1. Okay, so CD over AD actually equals to 2. CD over AD equals to 2. Here we will multiply this equality by 2 and we will get that CD equals to 2 times AD. And if we define CD as 2y, that is to say CD equals to 2y, then we will substitute CD in this equality by 2y and we will get that 2y equals to 2 times AD. Here we will divide this equality by 2 and we will get that AD equals to y. So we actually found out that if CD equals to 2y, then AD will be equal to y. So we can write here that if CD equals to 2y, then AD will be equal to y. Okay? So we actually have another rule. I will call it rule number 3. According to rule number 3, corresponding angles between parallel lines are equal to each other. Corresponding angles between parallel lines are equal to each other. So I will read rule number 3 again. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So actually, in our drawing, we have two lines that are parallel to each other. We know that DE is parallel to AB. So therefore, we can implement rule number 3 in our drawing because of the fact that DE is parallel to AB. So according to rule number 3, those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other. So that is to say, if angle BAC equals to alpha, then angle CDE will be also equal to alpha. So I write it down. According to rule number 3, angle BAC, this angle, will be equal to angle EDC and if one of the angles is equal to alpha, then the other angle will be also equal to alpha because of the fact that those two angles are equal to each other. So again, according to rule number according to rule number 3, those two corresponding angles that are located between parallel lines are equal to each other. So angle PAC equals to angle EDC, and if one of the angles is equal to alpha, then the other angle will be also equal to alpha. That is according to rule number 3. And if we look on the other side of triangle ABC, if we look on this side of triangle ABC, again we know that DE is parallel to AB, therefore those two corresponding angles that are located between the parallel lines DE and AB will be also equal to each other. That is to say, angle ABC will be equal to angle DEC. Because of the fact that those two corresponding angles are located between the parallel lines DE and AB, therefore they are equal to each other according to rule number 3. And if one of the angles equals to beta, then the other angle will be also equal to beta because those two angles are equal to each other. Okay? Again, the corresponding angles ABC and DC are equal to each other according to rule number 3, because they are located between parallel lines DE and AB, and if one of the angles is equal to beta, then the other angle will be also equal to beta. So we actually found out that those two angles are equal to each other and they are both equal to alpha, and those two angles are also equal to each other and they are both equal to beta. So if we focus on the big triangle, triangle ABC, and the small triangle, triangle CDE, we actually will prove that those two triangles are similar to each other. Okay, we will focus on the two triangles, triangle ABC and triangle CDE. On those two triangles, we know that angle BAC in triangle ABC is equal to angle CDE on triangle ABC, and they are both equal to alpha. Okay, that is what we have already found out according to rule number 3. Angle BAC equals to angle CDE equals to alpha. And we also know that angle ABC in triangle ABC, angle ABC on triangle ABC is equal to angle DEC on triangle DEC. And both those two angles are equal to beta. Again, angle ABC equals to, in triangle ABC equals to angle DC on triangle DEC, and both those two angles are equal to beta. And we also know that this angle, angle C, is a common angle because angle C belongs both to triangle ABC, the big triangle, and angle C also belongs to triangle CDE. So angle C is a common angle, so we can write down that angle C equals to angle C. It is a common angle. Okay, angle C equals to angle C. So we actually proved that the three angles of triangle ABC are equal to the three angles on triangle CDE. Therefore, we proved that triangle ABC is similar to triangle CDE according to angle similarity rule. So I will write it down. We actually proved that the big triangle, triangle ABC, is similar, that is the sign of similar, is similar to triangle CDE according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is a rule that states that if you prove that three angles of one triangle are equals to three angles of another triangle, you actually proved that those two triangles are similar to each other according to angle similarity rule. Okay, so from the fact that the triangle ABC is similar to triangle CDE, we can conclude that CD over AC is equal to DE over AB. I will repeat again, from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Okay, but what is the value of CD? The value of CD is actually 2y. And what is the value of AC? AC equals to AD plus DC, that is to say AC equals to y plus 2y. That is to say ACA equals to 3y. So in total we got that 2y over 3y equals to DE over AB. Two y over 3y equals to DE over AB. Y over y is 1, so y will get cancelled. And what is left after we cancelled y? What is left is DE over AB equals to 2 over 3. Okay, so here we will multiply this equality by AB and we will get that DE equals to 2/3 AB. So we got the equality that states that DE equals to 2/3 AB. Okay, so in the next step I will present to you a new rule number 4. Rule number 4 is true in any triangle. So in any triangle, so actually if we have triangle ABC that could be any triangle, this is triangle ABC, and we know that side AB of triangle ABC equals to A units, side AC of triangle ABC equals to B units, and side BC of triangle ABC equals to C units. Okay, so actually rule number 4 states that the sum of two sides of a triangle is always bigger than the length of the first side. That is the first part. I will write it down. I'll write down the first part of rule number 4. The sum of two sides of any triangle is always greater than the length of the third side, so Actually, in our drawing, uh, the sum of side AB and side AC is A plus B. So A plus B is greater than the length of side BC, that is C. So A plus B is actually greater than C. That is the first part of rule number 4, that states that the sum of the two sides of a triangle is always greater than the length of the third side. That is to say, AB is always will be greater than the length of BC, that is C, or AB is greater than C from one side, but from the other side, the second part of rule number 4 states that the difference between two sides of any triangle is smaller than the length of the third side. I will read the second part again. The second part of rule number 4 states that the difference between two sides of any triangle is smaller, or is always smaller than the length of the third side. So the meaning of the second part of rule number 4 is that the difference between two sides of the triangle is actually A minus B. A minus B in its absolute value will be smaller than the length of the third side, and the length of the third side is actually C. So the absolute value of A minus B will be smaller than C. Okay, so actually this inequality is the summary of rule number 4. It states that C is smaller than A plus B, that is the sum of two sides of the triangle ABC, and C is bigger than the difference between two sides of the triangle, that is actually A minus B, or C is bigger than the absolute value of A minus B. Okay, so I will read rule number 4 again. Rule number 4 states that the sum of two sides of any triangle is always greater than the length of the third side. That is to say, in this triangle, that could be any triangle, A plus B will be always greater than C from one side, but from the other side, the second part of the rule number 4 is that the difference between two sides of any triangle is smaller than the length of the third side. The difference between two sides of the triangle, that is A minus B, is smaller than C. Or A minus B, the absolute value of A minus B, that is the difference between two sides of the triangle, will be smaller than the length of the third side, that is to say, will be smaller than C, or the absolute value of A minus B will be smaller than C. Okay, so we actually can implement rule number 4 in our triangle ABC. If we relate to side AB of triangle ABC, we know that AB will be smaller than CA plus CB from one side, but from the other side AB will be bigger than CA minus CB in its absolute value. CA minus CB, absolute value of CA minus CB. So actually this inequality is the implementation of rule number 4 in our drawing, or in our triangle ABC. It states that AB from one side is smaller than CA plus CB, that is the sum of the sides, the sum of the two other sides of the triangle, but AB from the other side is bigger than the difference between the two other sides, that is to say, is bigger than CA minus CB, or it is bigger than the absolute value of CA minus CB. That is actually according to rule number 4. Okay? But we know that CA equals to 2 units. It is given us in the question. So CA equals to 2, when we know that CB equals to 8 units. So we will get that AB equals to CA minus CB. CA is 2 and CB is 8, so it is 2 minus 8 in the absolute value. And AB is smaller than CA is 2 and CB is 8. So we got that AB is smaller than 2 plus 8 is 10, and it is bigger than the absolute value of 2 minus 8 is minus 6. And what is the absolute value of 6? The absolute value of any number is the distance of the number from 0. And the distance of minus 6 from 0 is 6 units. Therefore, the absolute value of minus 6 is 6. So we got that AB from one side is greater than 6 and it is smaller than 10. Okay, but we have already found out that DE equals to 2/3 AB. Here we found out that DE equals to 2/3 AB. Okay? So here we will multiply this inequality by 2/3, and we will get that 2/3 AB will be smaller to 2/3 times 10 from one side, but from the other side it will be bigger than 2/3 times 6. So actually 2/3 AB, it is smaller than 2 times 10 is 20, and 20 over 3 is 6.66. And it is bigger than 2 times 6 is 12, and 12 over 3 is 4. So we actually found out that 2/3 AB is greater than 4. 2/3 AB is greater than 4 from one side, but from the other side, 2/3 AB is smaller than 6.66. But what is the value of 2/3 AB? The value of 2/3 AB is actually DE according to this equality. So we can substitute 2/3 AB by DE. Okay, and we will get that DE is smaller than 6.66 from one side, but it is bigger than 4 from the other side. Okay, so here, after we substituted 2/3 AB by DE, we got this inequality, and DE is bigger than 4 and it is smaller than 6.66. But we know also that DE is a natural number. According to what is given us in the question, DE is a natural number. DE belongs to the natural numbers. So which numbers we have, which natural numbers we have that are greater than 4 and that are smaller than 6.66. We have only two natural numbers that satisfy these requirements. The two natural numbers are 5 and 6, so DE will be equal either to 5 units or to 6 units. Okay? The value of DE is either equals to 5 units or to 6 units, so the answer to the question is that the size of DE, the size of line segment DE, will be equal to either 5 units or to 6 units. Okay, so that is the answer to the question. And now I will summarize the lecture. Actually, we wanted to find out the value of line segment DE, that we know that is a natural number. And we also know that AC equals to 2 units. And we know that CB equals to 8 units. And we also know that line segment DE is parallel to AB. And we also know that point G is the centroid of triangle ABC. So, what is the centroid of any triangle? The centroid of any triangle is the point where the three medians of the triangle intersect. Again, the centroid of any triangle is the point where the three medians intersect with each other. Okay? And we actually have rule, I called it rule number 1. According to rule number 1, the centroid of triangle G divides the median in a ratio that equals to 2 to 1. Again, the centroid of triangle ABC is G, and this centroid G divides the median AD in a ratio that equals to 2 to 1. That is to say, if AG equals to 2 units, then GD will be equal to 1 unit. Okay, so according to rule number 1, if AG equals to 2 units, then GD will be equal to 1. That is to say, actually AG is twice as large as GD. We can write down that AG equals to 2 times GD. That is according to rule number 1, and we actually can implement rule number 1 in our drawing. Why? Because in our drawing we have here the centroid G of triangle ABC. So according to rule number 1, the centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit according to rule number 1. If CG equals to 2 units, then GF will be equal to 1 unit, or in other words, CG is twice as large as GF, so we can write down that CG equals to 2 times GF. Okay, so that is all according to rule number 1. According to rule number 1, CG equals to 2 times GF, and if we define CG as 2x, that is to say CG equals to 2x, so we can substitute CG by 2x, and we will get that 2x equals to 2 times GF. We will divide this equality by 2, and we will get that GF equals to x. So we actually found out that if CG equals to 2x, then GF will be equal to x. So we can write here that if CG, this line segment equals to 2x, then GF will be equal to x, according to rule number 1. Okay, so in the next step I presented to you another rule, rule number 2. Rule number 2 applies in any triangle. So in any triangle ABC could be any triangle. If in triangle ABC we know that line segment DE is parallel to BC, then according to rule number 2, AD over DB will be equal to AE over EC. Again, in triangle ABC, if we know that DE is parallel to BC, then according to rule number 2, AD over DB will be equal to AE over EC. And again, we can implement rule number 2 in our drawing, because if we relate to the green triangle, triangle CAF, in triangle CAF, we know that DE is parallel to AB. So according to rule number 2, because of the fact that in triangle ACF DE is parallel to AB, the following equality is true, that CD over DA equals to CG over GF. Again, CD over AD equals to CG over GF. That is according to rule number 2. But what is the value of CG? CG equals to 2x. CG equals to 2x. And what is the value of GF? GF equals to x. GF equals to x, so we got that CD over AD equals to 2x over x. So x over x is 1, so x will get cancelled. So we found out that CD over AD equals to 2. CD over AD equals to 2, and if we multiply this equality by AD, we will get that CD equals to 2 times AD. Okay, so if we define CD as 2y, that is to say, if CD equals to 2y according to our definition, then we can substitute CD by 2y, because CD equals to 2y, and we will get that 2y equals to 2 times AD, and if we divide this equality by 2, we will get that AD equals to y. So we actually found out that if CD equals to 2y, then AD will be equal to y. So we can write here that if CD equals to 2y, then AD will be equal to y. Okay, then we actually have rule number 3. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So actually we can implement rule number 3 in our drawing, because in our drawing we have two lines that are parallel to each other. DE is parallel to AB, so according to rule number 3, those two angles that are corresponding angles and that are located between the parallel lines DE and AB will be equal to each other. So that is to say, if angle BAC equals to alpha, then angle EDC will be also equal to alpha. So we can write down that according to rule number 3, angle BAC equals to angle EDC, because there are two corresponding angles that are located between the parallel lines DE and AB. And if one angle equals to alpha, then the other angle will be also equal to alpha because of the fact that they are equal to each other. And we can implement the rule number 3 also on the other side of triangle ABC. Here we have two corresponding angles that are located between the parallel lines DE and AB. Therefore, those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other, according to rule number 3. So, angle ABC equals to angle DEC, and if one angle equals to beta, then the other angle will be also equal to beta, because of the fact that they are equal to each other. Okay, so we actually found out that those two angles are equal to each other and they are both equal to beta, and those two angles are also equal to each other and they are both equal to alpha. Okay, then we actually proved that the big triangle, triangle ABC, is similar to the small triangle, triangle CDE. Okay, we focused on the big triangle, triangle ABC, and on the small triangle, triangle CDE, and we proved that those two triangles are similar to each other. First of all, we have angle BAC, this angle on triangle ABC, that is equal to angle EDC on triangle EDC, and they are both equal to alpha. So angle BAC equals to angle CDE, and they are both equal to alpha. And also we have here angle ABC on triangle ABC that is equal to angles DEC on triangle CDE, and they are both equal to beta. Angle ABC equals to angle DEC, and both those two angles are equal to beta. And the third angle, this angle, angle C, is a common angle because angle C belongs both to triangle CDE and angle C also belongs to triangle ABC. So angle C equals to angle C is a common angle that belongs to both triangles. So we actually proved that three angles of triangle ABC are equal to three angles on triangle CDE. Therefore, we proved that triangle ABC is similar to triangle CDE according to angle similarity rule. And what is angle similarity rule? Angle similarity rule states that if you prove that three angles of one triangle are equal to the corresponding angles, the three angles of the corresponding angles on the other triangle, you actually proved that those two triangles similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Okay, CD over AC equals to DE over AB. What is the value of CD? The value of CD is 2y. Here, the value of CD is 2y. And what is the value of CA? CA equals to CD plus DA. So CA equals to CD, that is 2y, plus DA, that is y. That is to say CA equals to 2y plus y. Okay? So CD equals to 2y and AC equals to 2y plus y. In total we got that 2y over 3y equals to DE over AB. Y over y is 1, so y will get cancelled. And what is left after we cancelled y? What is left is DE over AB is equals to 2 over 3. Here we multiplied this equality by AB and we got that DE equals to 2/3 AB. So we got the equality that states that DE equals to 2/3 AB. Okay, then I presented to you rule number 4. Rule number 4 states that two sides, the sum of two sides of any triangle is always will be greater than the length of the third side from one side, and from the other side the difference between two sides of any triangle will be always smaller than the length of the third line. So I read rule number 4 again. Rule number 4 states that the sum of two sides of any triangle is always greater than the length of the third side. That is to say, here A plus B will be greater than C from one side. And the second part of rule number 4 is that the difference between two sides of any triangle is smaller than the length of the third side. That is to say, A minus B, the absolute value of A minus B will be greater than C. So this inequality summarizes rule number 4. According to rule number 4, C from one side is smaller than A plus B, but from the other side, C is greater than the absolute value of A minus B. Okay, so we again can implement rule number 4 in our triangle ABC. On triangle ABC, if we relate to side AB of triangle ABC, we can state that AB is smaller from CA plus CB from one side, but from the other side, AB will be bigger than CA minus CB, or the absolute value of CA minus CB. That is the implementation of rule number 4 in triangle ABC. Side AB of triangle ABC is smaller than the sum of the other two sides. That is to say, AB is smaller than CA plus CB from one side, but from the other side, AB is bigger than the difference between the two other sides. That is to say, CA minus CB, or it is greater than the absolute value of the difference between the two sides. That is to say, AB is bigger than the absolute value of CA minus CB. And we know that CA equals to 2 units and CB equals to 8 units. So the absolute value of 2 minus 8 is minus 6. And the absolute value of minus 6 is actually, what is the absolute value of any number? The absolute value of any number is the distance of the number from 0. And the distance of minus 6 from 0 is 6 units. So the absolute value of minus 6 is 6, and AB is smaller than 2 plus 8 is 10. So we got that AB is greater than 6, but it is smaller than 10. But we also know that DE, we have already found out that DE equals to 2/3 AB. Here we multiply this inequality by 2/3, and we get that 2/3 AB equals to 2/3 times 6, or 2/3 AB is greater than 2/3 times 6, and it is smaller than 2/3 times 8. Here 2/3 times 6 is 4, and 2/3 times 10 is 6.66. But we know that 2/3 AB equals to DE, so we can substitute 2/3 AB by DE, because DE equals to 2/3 AB. So we substituted 2/3 AB by DE, and we got that DE is greater than 4, and it is smaller than 6.66. But we also know that DE is a natural number. It is given us in the question that DE is a natural number. So which natural numbers we have that are greater than 4 and that are smaller than 6.66? We have only two natural numbers that satisfy these requirements. The two natural numbers are 5 and 6. So we found out that DE equals to either 5 units or 6 units. So the final answer to the question is the size of DE is either 5 units or 6 units. Okay? Thank you very much.